Okay, this module we're going to talk a little bit about security and how to secure our system. And the first thing you need to worry about when you're securing a system is what you want to do to secure the system. What settings you need to change to what values and all that kind of stuff. Ideally, systems would come with security built in, and they're getting better. But there's still a lot that can be changed to improve things with regard to security. So where do you go to find out what you should change? Well, the very beginning, you should find some resource that knowledgeable people have put together. In this case, there's a copy of the CIS Red Hat Enterprise Linux 6 benchmark, which is, Red Hat's essentially the same thing as CentOS. CentOS strips out all the Red Hat stuff. So this is a document that tells you things you should, settings you should change and stuff. We're not going to go through all of this, but this is where you could start. You look at this and see how it fits in your environment and make sure that anything in here that's relevant to your environment you do. So like, for example, it says remove HTTP server. This is in the table of contents. Well, if you go down there to that section, it's probably going to say, if it is not needed, remove the HTTP server. If you're running a web server, right, production web server for your company, and you're applying a benchmark and you get to a step that says remove HTTP server, do you think you should remove the HTTP server from your company's production web server? I hope not, right? So as you go through here, there's some changes that need to be made, and some don't need to be made, and some that are already set the way the recommendation uh, recommends that it be set. So that's where you can go to start with. This is the operating system level secure configuration guide, right? So this is the main system itself, and this one is let's see, 184 pages at least. So pretty long, pretty thorough document. Once you secure the base OS, then you need to start considering any additional software you have installed. So here is a Apache security configuration guideline. So as we go down through here, same thing. Enable the log config module, disable WebDAV, disable status and info modules, disable auto index modules. So this gives you a lot of settings you can do to make your web server more secure. It's less pages and 76 pages. So again, should you go through and automatically do everything in there? No, you shouldn't. What likely should happen is that someone knowledgeable at your organization, whether that's you or an architect or an IT manager or whoever it may be, should review these types of documents and then come up with a security standard for your organization. So I've done that for us. I've created this tiny little security standard. It has 14 items in it at this point. I'm not going to promise that it's not going to grow to include more items, but I didn't want it to be too complex, and I also didn't want us to get too deep into the weeds, so I made it fairly simple. But this is what our security standard is, and this is what we're going to implement over the next few modules, and it's what we're going to try to conform to throughout the rest of the class. So as you guys may remember, I rearranged things a little bit. I had the security module scheduled for a little later on, but then it got to the point where I was thinking about what we were actually going to be doing, and if I didn't teach you how to modify security stuff, then you essentially would have had to turn off security in some instances in order to test things. And I thought that was a bad lesson for me to teach you. One of the big problems we have is that many times in development process and implementation process, everybody wants to save security till the end. Like, oh, security's hard. Let's just get it working now, and then we'll go back later and put the security in. So, as you may imagine, sometimes schedules get run over and things aren't going well, and you're at a rush at the end to get things done. And if you're saving security until the end and you're already over schedule, how likely is it that you're going to do a great job doing the security part? I'd say it's probably not very likely. So that's why we do security now. We're going to do security now so we can learn what we need to do to make things work, and then we'll keep our system secured in a secure manner for as long as we can. So let's go over this security standard I've put together for us quickly. The system must operate at run level 3 with no graphical user interface. So if you look at the RFCs, there are words that are used in the RFCs. If you're not familiar with RFCs, it stands for Request for Comment. You can go read them on the IETF page. Essentially, those are the documents that describe our protocols that we use and how they should work. So there's some words that are used in there: must, must not, should, and should not. Anything that says must or must not is a requirement. Anything that says should or should not is a recommendation. So I don't think I have any shoulds. I think I have all musts because these are things that I wanted us to be able to do. So all of these things are requirements. Some of them won't be implemented this module. There'll be some follow-on podcasts to describe how to implement these things as we go along. But these are what we're going to consider our security standards. So number one, the system must operate at run level 3 with no graphical user interface. So run level 3 doesn't start the GUI. We'll learn more about the run levels at the processes next module, so we won't do anything with that one right now. The system time must be synchronized with an NTP server. NTP is network time protocol is how we get our time from a time server. We want the time to be synchronized so that if we are trying to correlate events across multiple devices, for example, we were compromised and we have log files from the firewall and from the routers and from the Windows host and from the Windows server and from the web server, we want to be able to know with some certainty that the time stamps will match up. And if we are all synchronizing to a time server, then we can feel pretty confident that those timestamps will match up, and that will aid us in the forensic process of recreating what happened. The system must be configured to log remotely. If someone hacks your server and gets full control of it, they can delete the log files. So logging remotely is a way that you can hopefully try to prevent them from being able to completely get rid of all of the log files. So if they're on your log server and it's more tightly controlled, then they won't be able to in theory, get rid of the logs on that server. All users must log in using SSH with key-based authentication. So remember, we created keys. I said I was going to disable passwords. Well, I didn't actually disable passwords, but we're going to actually disable passwords on our own server and force key-based authentication. The system must not allow clear text management or file transfer. So we can't use Telnet, rlogin, FTP, TFTP. So we'll check to see if those are running. If they're running, we'll have to turn them off in theory. The root user must not be able to log in directly. So best practice is you force people to log in with a regular user ID and then use sudo or su to become root. We're going to use sudo. If you look at the next item, it says administrative users must use sudo to run commands with elevated access. We're going to do that for management. Again, there'll be podcasts to go over how we do that a little later on. SSH access must be restricted to certain IP addresses using IP tables and or TCP wrappers. IP tables is the built-in Linux firewall. TCP wrappers is another level of access control where you can control access to specific programs based on source IP address. The IP tables firewall must be running and should only allow inbound access to required services. So that means we should only let people in for SSH, and as we add services to our server, we'll be modifying the firewall in order to allow access to those new servers and services. The IP tables firewall must be configured to log dropped SSH packets. By default, IP tables does not log any dropped packets, and for the most part, we may or may not care about what gets dropped. But in the case of SSH, if it's getting dropped, that means somebody else is trying to connect to our server in order to gain access. And if they're trying to connect from an IP address that's not in our list of allowed IP addresses, then we might want to know about that. Unnecessary serves. Let me fix that. Unnecessary services must not be running and must not get started at boot time. So for our servers, we did the minimal install. So for the most part, that's probably going to be pretty clean. We'll actually take a look and see what's running and see how we determine what gets started at boot time. But for now, just keep in mind that there might be some services that we need to turn off and disable. Number 12, this isn't something we'll actually be able to check, but this is a good thing to have in a security standard, a conversation about when updates should be installed. Number 12, system updates should be applied in a timely manner. Timely is determined based on the classification of the system. So normally you want to have some sort of phased implementation plan. You don't want to roll the patches out to production first thing, because then if that breaks something, you've broken production. So in our case, with my security standard, development must be patched within 24 hours of release. Test must be patched within 24 hours of successful deployment to development. Production must be patched within 24 hours of successful deployment to test. So we're looking at 96 hours to get our entire environment patched, which is pretty good. I recently talked to somebody who was talking about patches and what he had seen when he would do some auditing of different organizations. He would look at the patch windows, and they say, "Oh yeah, we have 30 days to install patches." He'd be like, "Really, 30 days?" It's like, "Yeah, well, we have to test and whatever." It's like, "So when do you actually start testing?" They're like, "We actually start testing about day 28." So you don't actually take 30 days to do the testing? Oh no, we don't. That's just how long it takes us to schedule and blah blah blah. So that organization severely cut down their patch window, and they were able to actually successfully do it. So we have a small patch window, which is good. Number 13, updates for remotely exploitable flaws to publicly accessible services must be patched within 12 hours of release in all environments. So what does that mean? Let's take that piece by piece. Remotely exploitable flaws. So that means there's a flaw that somebody can exploit over the network to publicly accessible services. What does that mean? That means it's a service that anybody can get to. So some examples of that would be a web server, right? We don't usually limit who can get to our web server. A mail server, we don't normally limit who can get to our mail server. DNS server, we don't normally limit who can get to our DNS server. SSH, we're going to limit who can get to SSH to known IP addresses. So that would not apply if we're talking about SSH, because we're going to limit who can get to SSH. So remotely exploitable to publicly accessible services. So mail, web, DNS, those things that anybody can get to must be patched within 12 hours of release in all environments. So if it is something that people on the internet can connect to, then we need to get that patched immediately. Number 13, all system administrators must submit an initial system baseline to the security manager before the system can be placed in service. One of the big things with security is if you don't know what's supposed to be going on your system, then it's hard to determine what is wrong when things start acting weird, right? So what do you do if things are acting weird? Well, you go look and see what services are running, and you look at what ports are listening. But if you didn't know what was listening before, then you don't really know definitively what everything is. So what we're going to do is create a baseline where we're going to run some commands that collect some information about the server, and we're going to save that information in a file, and then we're going to store that file offline somewhere. So in my security standard, it says you must submit your baseline to the security manager before the system can be placed in service. So the security manager is me. What I would do if this was a real world and I was checking your system, I would look at your baseline to make sure that you had configured it in a manner that met our security standard guidelines before I would allow you to place it in service. So there'll be another podcast. I'm not going into a lot of details about the baseline, but there'll be another podcast to show you how to create the baseline and how you can use it to verify the server later on. 14, an updated system baseline must be submitted anytime the server configuration is changed. So say you determine that you want to install, some new package that you need for your web app to work properly. Well, that's fine and good, but before you do that, you should validate the system against the current baseline to make sure that nothing unexpected has changed, and then you should create a new baseline and store that offline so that later on, if you see something has changed, then you can get that baseline and verify against that. And then I forgot one other thing I was going to put in here. I'll go ahead and put that in now. Number 15, any deviation from the security standard must be approved in writing by the CEO. I don't know. So what does this mean? Well, right, any deviation. Why is that underlined? It doesn't like my passive voice. Fine. The CEO must approve Jesus, I can't write. Approve any deviation from the security standard in writing. That's not passive voice anymore. Oh. All right, the CEO must approve any deviation from the security standard in writing. So does that mean that you can't deviate from the security standard? No, right? Up here it says the system must not allow clear text management, right? Telnet, RLogin, FTP, TFTP. So those clear text protocols create a risk, but there might be a valid business case while it's legitimate to use one of those protocols in some situations, right? TFTP is a protocol that we use to get our router and switch configs off the devices. So it might be reasonable for us to have a TFTP server somewhere, but you know it's an exception to our security standard, and it needs to be approved because anytime there's an exception to the standard, we need to evaluate the risk that creates in our environment, and then we can determine if we need to provide any extra protections to that server. For example, going back to our network device configuration example, if you are TFTPing your router configs off of the router, your router config may or may not, well, your router config will have some password information in it that may be easily recoverable if someone was to get the config. So there may be some additional protections you want to put in place on that server. Instead of letting everybody log into that server that can normally log into all the servers, maybe you want to limit it to just the network team. Or maybe you want to put a policy on that says, you know, the passwords, somebody must go sanitize the files after they're copied up to take the passwords out or something like that. So that's generally just a good practice to have a statement that says any kind of exception must be approved. Why the CEO? Could it be the IT manager, the IT director, the CIO, the CISO? Well, it could be, but the CEO is the one that's ultimately responsible for the business to the stockholders, if there are any stockholders. So, you know, let's just go all the way to the top. That's how my organization is going to work. You're going to have to go all the way to the top. The CEO is going to have to approve it. So that's the standard we're going to work from. Over the next 3 weeks, we'll be configuring things to meet the standard. There'll be some podcasts for how to implement this, and you should go watch those so you can implement this in your environment with your server.